So now we're going to simplify some of these square roots. If you have something like the square root of 9, nobody ever leaves it like that. They write it as 3. So that means if you have something like the square root of, say, 45, this does not come out nice. It doesn't come out nice at all, but we're talking about the number that times itself to give you 45. So it should be somewhere like 6.5, 6.6, I don't know, somewhere in there. Almost up to 7, but not quite. There is a 9 in here. We could rewrite this in really slow motion as the square root of 9 times the square root of 5. Let's write it like this. Square root of 9 times the square root of 5. And this becomes 3 square roots of 5. And that is simplified. If we times it by something, say the square root of 20, see what happens here. This, does it have a perfect square, a nice square that will go into it? Think about what the squares are. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. This has the number 4 in it. Now that's crucial because we could have written this as square root of 10 times 2, but neither one of those simplifies. But we've got to take out what we can. So in super slow motion, we're going to write that as square root of 4 times the square root of 5, and that's 2 square roots of 5. Now when we times these, this becomes 3 times 2 times the square root of 5 times the square root of 5. That is 6. Now the square root of 5 times the square root of 5 turns out to be really nice. In slow motion, it's the square root of 5 times 5, which is 25. Square root of 25 is 5. Or you can see, what is the square root of 5? It's the number that when you times it by itself, you get 5. So that's how this simplification will help us. The other thing is, let's say we did this, and instead of multiplication, let's do addition. So if we were to add these two things together, 3 square roots of 5 plus 2 square roots of 5? What if we had something like 3x plus 2x? You're like, well, that's easy, that's 5x. What about 3m plus 2m? Well, that's 5m. How about 3 apples plus 2 apples? That's 5 apples. How about 3 square roots of 5 plus 2 square roots of 5? That'd be 5 square roots of 5. When these things are alike, you can add them. It's just like combining like terms. So you just add them together when they are alike. So this allows us to go even a little bit better on that. And let's do something like the 5th root of 243, x to the 9th, y to the 7th. Something like this. Now here, we're taking 5th roots, and if we're going to simplify this, we can only take out perfect 5th powers. Now is 243 a perfect 5th power? Better look on your chart, see if you can find it, or oh no, you've got to memorize now, never mind. So 243 is 3 to the 5th. So this guy can come, 5th root of 3 to the 5th is 3. Now this guy could be written as x to the 5th, x to the 4th. That is a perfect 5th. 5th root of x to the 5th is just an x. And this guy can be written as y to the 5th, y squared. That's a perfect 5th. So 5th root of y to the 5th is a y. Anything that was not a perfect 5th has to stay home. Unable to go anywhere. And that's how you can simplify 5th root, 6th root, 7th root, square root, whatever you have. And the final thing we're going to do here is we're going to take something, an expression such as 3 divided by the square root of 7. You're going to be given instructions to rationalize the denominator. Rationalize the denominator. Now, what does that mean? You recall that a rational number is one that can be written as a fraction. And those that are irrational are like square roots and pies. Well, look at this. This guy right here, the denominator is irrational. So what we're going to do is a trick we learned way back when. You remember we took like 2/3 and we said, hey, this is the same number as 4/6. Or we could times by 7 and 7 and we get 14 over 21. or times by 9 and 9, and we get 18 over 27. That we were able to change this fraction into a different, a different name for the same number. Well, here we are going to do the exact same thing. We're going to times by something on top and bottom that will turn this bottom guy, the denominator, into a rational number. Well, we could pick a lot of things. The easiest one is timesing by the square root of 7. Watch what happens. We get 3 square roots of 7 on the top, and what's on the bottom? Square root of 7 times square root of 7? What is that number? Well, it is the number 7. The long way is to 7 times 7 is 49. Square root of 49 is 7. The short way is to realize the square root of 7 is that number that when you times it by itself gives you the number 7. Let's try another one to make sure you're okay with that. 5 over the square root of 11. You're going to times by square root of 11 over square root of 11. Now the top is irrational, but we have rationalized the denominator. Square root of 11 times square root of 11 is 11. A little bit of a tricky thing here. If I did 5 over, say, the 4th root of m, something like that, it's not going to work to just times by the 4th root of m. We're not going to get anywhere with that. We have to times it by something that will cause it to be m to the 4th, so it can undo that 4th root. So I'm going to times it by the 4th root of m cubed. Then what happens is it actually comes out 5 m 4th root of m cubed. That's kind of ugly on the top, but the instructions were to take care of the denominator, and that's the 4th root now of m to the 4th power. And there we have rationalized the denominator.